So let us quickly look at the last part of Module 2, that is Module 2.3, Basic Concept 3. We're going to look at some introductions just briefly, analysis, excess air, illustration, and then we'll conclude. Composition of gases, liquid and solid. By convention, the composition of gases are given on molar basis, while the composition of liquids and solids are given on a weight basis. The composition of gases are always given as percent by volume. Here, percent by volume means the same as mole percent. This is as a result of the fact that gas analyses are done at 1 atmosphere, where all gases behave essentially as ideal gases, and the number of moles is proportional to volume. So you can see the basis of that. At that 1 atmosphere, we can essentially say that all gases behave as ideal gases. Now, analysis. Analysis of these gaseous substances are very important. Different types of gas analysis exist, as we see below. One is flue or stack gas. This is also known as wet basis. So when we talk about flue or stack gas, we're talking about wet basis. It includes all the gases resulting from combustion process and the water vapor. That's why it's wet basis. Aussat analysis or dry basis. This is all the gases from the combustion process, but not including the water vapor. The ultimate aim in Aussat analysis is to remove the water vapor. Theoretical air. This is also called required air or oxygen. It is the amount of air required to be brought into process for complete combustion. Excess air. You see, we're emitting excess air again, just like we have met excess reactant. So this is excess oxygen, just like excess reactant. So it is the oxygen in excess of that required for complete combustion. We say it's excess air. And the excess air, to calculate this, it does not depend on how much material is actually burned out, but what can be burnt. Even if only partial combustion takes place, the excess air is computed as if the process of combustion produced only CO2. So percent excess air may be calculated as follows. Percent excess air equal to oxygen entering process minus oxygen required divided by oxygen multiplied by 100. Or percent excess air equal to excess oxygen divided by oxygen entering minus excess oxygen multiplied by 100, equation 2. Since oxygen entering process is equal to oxygen required for complete combustion plus excess oxygen, you see, that's why we can use either equation 1 or 2. Now, the precision of these different relations for calculating percentage excess A may differ. If the percent excess A and chemical equation are given in the problem, then we're talking about what enters as fuel, and hence the number of unknowns will be reduced. So all these things depends on the problem we actually want to solve. Now look at an illustration. Compressed propane has been suggested as a source of power for vehicles. Suppose 20 kg of propane is burned with 400 kg of air to produce 44 kg of CO2 and 12 kg of CO. What was the percent excess air? So that's the equation. Propane is burnt in oxygen to give CO2 and water. Now the basis is 20 kg of propane, and that's what is given. So required oxygen 20 kg multiply. If you look at the equation, the propane is 1 mole, oxygen is 5 moles. So if we convert to kg, we'll be talking about kilogram mole. So 1 kilogram mole of propane and 5 kilogram mole of oxygen. So we'll have 2.27 kilogram mole of oxygen. Therefore, entering oxygen will be 400 kg of air We are given that in the question 400 kg of air produces 44 kg of CO2. So 400 kg of air will now give us 2.9 kg of oxygen that is entering. So which means excess, look at what is entering, look at what is used. Excess will be excess oxygen divided by required oxygen multiplied by 100. So which is 2.90 minus 2.24 divided by 2.27. This gives us 28%. Thank you very much. This is very short because we just looked at only different types of analysis and then looked at illustration. And this brings us to the end of Module 2. It will take time. Very shortly. We'll also be discussing Module 3 and then Module 4, which will be the final for this course. Thank you very much, and I'm very much sure you enjoy the class. See you in the next module. Thank you.